Well, here we go, round 2 of exponential word problems, and the last official video notes for this school season. I know that that's probably going to make some of us a little sad. Certainly makes me sad, but what a way to end with word problems. Everybody's favorite. All right, so we're still talking about exponential functions, and we know an exponential function is written in the form y equals a parentheses b to the x. And again, remember, it's important that we have this b to the x in parentheses because only the base b will be raised to that exponent, and that has to be done first in our calculation before we can multiply by a, that initial value. All right, and so, so far the b values have been given as something like 2 because it says that we're doubling every year. Or the b value has been given something like 1/2 because it says that we're cutting in half, half of previous, okay? And so, that's not a percentage. That's just giving the actual number that you're going to be multiplying by, right? If I'm tripling by something, I'm going to have a base of 2. If I'm 3/4 of the previous, my base is going to be 3/4. And so it's been very straightforward what the b value is. It's given in the scenario. But what if the rate is given as a percentage? That rate as a percentage. Okay, so for example, if I say, hey, the amount that my money is increasing by is 10%. Well, I certainly do not put 10 in for B. If I put 10 in for B, that means my money is multiplying times 10 every time, okay? And, 10% converted to a decimal, 10 divided by 100 is 0.10. If I put 0.10 in for B, that looks like my money is going to actually decrease because remember, 0.10 is between 0 and 1. 0.10 would be decay, actually, because it's less than 1. We said in order to be growth, this b value had to be bigger than 1. Okay, so let's just put that down as a reminder. Growth is when the b value is bigger than 1, and decay is when the b value is between 0 and 1. So we get in this interesting scenario where for percentages, I have to say, 10%, 10 divided by 100 is actually 0.10, and that's the number that I'm going to use as my rate. But I know that my scenario should be exponential growth because it says I'm increasing, and so I can't put 0.10 in for B because 0.10 would be decay. So what happens? Well, what this really means is that we end up having something that looks like this. We end up with y equals a, and then 1 plus or minus that rate to the x, okay? This 1 right here represents the fact that I have 100% of what I started with, and then plus that percentage or minus that percentage, depending on if I have growth, then I'm going to use plus, or decay, then I'm going to use minus, okay? So again, if I have plus a percentage, I have growth, minus a percentage means that there's a decay situation. In other words, I'm going to start with 100% of my money. And I'm going to add 10% of that to my money. So it's like saying I have $500 plus 10% of $500. And that turns out to be my base, that 1 plus the new percentage. In other words, it turns out that this B value, gotta remember to switch to the pen. Last video and I still haven't figured it out. That B value really is a 1 plus or minus your rate. So when we are given a percentage, we have this extra step. This extra step where we have to figure out the B value, extra step to determine the B value, And we have to make a decision. If we're going to use the plus, it's because they have a growth situation. And if we're going to use the minus, it's because we have a decay situation. Okay? And again, when we talk about R equals the percentage divided by 100, or the rate. Okay? All right, so let's give a couple examples a try. Originally, there were 17 deer in the park. The population increases by 35% each year. So just like last time, I'm going to label these key pieces. This is my initial amount. So it's going to be my A value. Increases tells me that we're going to have growth by 35% each year. So X is in years. And 35%, well, I'm going to have to use that to help me find the B value. Okay, so is this growth or decay? Well, this is growth. And we said this is growth because I have the word increases. Determine the B value for the exponential function. So remember, now that we have this extra layer of percentages, the problem does not come out and say, oh, the population doubles, it triples, the population's cut in half. Those are given direct B values. I'm not given a direct B value. I'm given an indirect B value, okay? And so because of that, remember, B is equal to 1, in this case, plus R. And it's plus because we have exponential growth, okay? And so my B value is equal to 1 plus 35 over 100. Remember, a percent needs to be converted to a decimal in order to use it in this problem. If I just did 1 plus 35, that would be 36. And if my B value were 36, that means I'm taking 17 and multiplying that by 36 every year. That would be way too high, okay? All right, and so really what this gives me is 1 plus 0.35 or 1.35. And so we always simplify that B value down, okay? So anytime I have growth, it's always going to be 1 point, whatever that percentage is, okay? Because I'm adding the percentage as a decimal to 1. 1 representing the 100% of deer that I started with. I started with 17 deer in the park, plus I'm going to add 35% of 17. So 17 plus my new amount, okay? Write a function to model this situation. Well, again, we use the function y equals a times b to the x, and we have our new b value. So y equals 17, the initial amount. My calculated b value is 1.35 to the x. So again, this is the extra step. This stuff right here, this is the extra step. The step that we didn't have to do last time, okay? Because it was just, the B value is directly given to us. And now the B value is not directly given to us. We have this extra step. And once we figure out this extra step, we can put that right into our y equals a times b to the x. Find the number of the deer in 15 years. All right, so y equals 17 in parentheses times 1.35. And I'm going to replace x with 15. And again, we can use our calculator, we can use Desmos, doesn't matter. And when we do that, when we type that in, 17 times, in parentheses, 1.35 to the 15, I get 1532.69. I can't have partial deer, so I'm going to round that, 1533 deer. In fact, pay close attention to the directions in your Google Forms because it will tell you to round up to the nearest whole number. Unless we're talking money. And if we're talking money, then you can just keep that as 2 decimal places. Okay. All right, let's try another example. My car cost $23,000 new, and the value decreases by 9% each year. By the way, when you talk about money decreasing, that's called depreciation. Depreciation happens typically on cars. Rarely do they gain value unless they're really old. Then at some point they start increasing in value. Oftentimes real estate could depreciate, although these days real estate is appreciating, meaning it's increasing in its value, okay? But when an item decreases in its value or its worth, that's called depreciation. All right, so my car costs $23,000 new. That's my initial value. Decreases means I have exponential decay, 9% each year. So again, you know by now I like to label. This is my initial. Decrease tells me I'm going to have decay, decrease, decay. 9% is going to help me get my B value. Remember, 9 over 100, so 0.09, got to be careful there. And each year tells me that X is in years. Okay. And so we said this is going to be decay because my value is decreasing. Unfortunately, when you buy a vehicle and you drive it off the lot, it is no longer worth what you paid for it. This is why I always buy used cars. That and I get nervous about, putting a dent in my brand new car or spilling my pop or coffee, which would surely happen the second I drive it off the lot, things like that. Okay, determine the B value for the exponential function. Remember, my B value, because I have this extra percentage piece, I'm not directly told the B value, it's going to be 1 minus the R in this case. And it's going to be minus because we have decay. Right, I'm going to use subtraction to get smaller values. And so B is equal to 1 minus, we said 9 over 100, which is really 1 minus 0.09. You got to be careful with that decimal, okay? And 1 minus 0.09, when I clean this all up, is 0.91. Actually, what that means is that your car is worth 91% of its original value. Worth 91% of original value. I could spell, right? Okay. Which feels reasonable, right? That, I'm gonna be worth 91% of what I originally paid for it after 1 year, and then 91% of that, and then 91% of that, and I'm going to keep decreasing in value. And by the way, this works out to be decay because 91 is between 0 and 1. 0.91, I apologize. 0.91 is between 0 and 1. So it's just like an extra check mark that we have decay going on here. Okay, so now it says write a function to model the situation. Again, we are using that y equals a times b to the x. And so I have y equals, $23,000 is what I paid. 0.91 is my calculated b value raised to the x. Find the car's value in 5 years. Okay, so y equals 23,000 times 0.91, and in place of x, I'm going to write 5. And again, at this point, maybe you can hear me typing it in my calculator, right? At this point, you can use Desmos, your calculator, and we get 14,352 point. Now again, it's money, so you should always have 2 decimal places. I got 0.739, so I'm going to round that up to 0.74, and I'm going to put my dollar sign to label that, okay? And so, my car that started out as $23,000 5 years later, if I go to sell that and it's in good condition, I'm only going to get a little over $14,000 for it. Okay, seems reasonable. All right, so you only have 2 problems left on this Google form, this last graded assignment, okay? So best of luck and ask us questions if you have any.